So here we go. Brilliant. 들어갈게. Alright. So did you use similarity and cyclic? I'll use similarity and cyclic. Okay. Of course, there's something called Mequel point, but I don't know about the Mequel point or whatever. 그러니까 난 그걸로 못 풀겠어. I have no idea how to solve that. So I'll just follow through my own method and let's go through. Okay. 한번 해볼게. Right. Okay. So there are two circles. I gotta draw some nice circle. 너무 크게 그렸다. Because if you draw the circles, you guys will notice that pictures are gonna be super ugly, and you guys will notice that we are actually studying Aime. 이제 진짜 Aime구나. Okay. So these are omega 1 and omega 2, and these are x and these are y. Okay. All right. So there are tangents. So I gotta use some tangencies. And there's some point A and there's some point B. Okay. Right. Let's just try to label this as Z because we need it. Okay. All right. So the question is, there's circle omega passing through A and B, intersecting omega 1 at D and omega 2 at C. Okay, so probably you got to draw. I don't know how. I don't know whether I'm gonna be successful, but no, that's too big for this. Oh, okay. So yes, such that these are collinear. Oh no, wait. I'll fix this. Yes, totally fixable. Right, so that's D and this is C. Okay, so this is D and this is C. Are we all agreeing on this picture? 우리 여기까지 다 됐지? So here we go. We found that XC equals 67 and XY equals 47 and XD equals 37. So these are 37, these are 47, and these are 67. Okay, so we just jump. Now, you guys should notice that these are the radial axes. That's the first idea that all of us should agree. Because radial axis gives power points. Lots of power points. So what type of power points are we talking about? If you find some point out there, power of points equals these being the same, and power of points, of course I gotta draw some picture really nicely. Power of points equals that times this. So we get all those nice looking picture, okay? So any points on those radial axes giving us some power points. Now forget about the power points now. I just need to draw one full picture because I'm gonna use similarity, and of course I gotta draw that figure. Ooh. And of course I gotta draw. Ooh. Alright, so let's fix B. That's B. Let's try to call it point P, A, and D, all nice. Right. So we have an interesting picture. Okay? Because they all in the same the radial axis. The power points are all the same. They gotta be collinear. collinear 하니까 당연히 concurrent 하는 거지. 다 똑같은 거지.
Even Z?
Even Z? Yeah, of course. Z is already in the radial axis. Z is already in the radial axis. Already. I labeled it as in the radial axis. Alright, so we begin. That's a first setup. Okay? Setup number 1. Now, I claim we're done. What? Alright, so we're not really done. Here we go. And here we go. Do you notice that A, X, Y, D are cyclic? That this angle and those angle are what? Forming 180. But that's also 180. Okay? Now, check this out. We get some angle out there and some angle out there, and they're 180. Does that make sense? Like these are opposite angles of what we see one another in the cyclic quadrilateral. So you see that A and B are in fact forming 180. So there must be a circle. So there must be a circle out there. And I really claim that we're also done. Why? Because we have found an interesting object. So we begin by drawing some other line. I'm going to use different color from that one. So check this out. What do you know about this angle right here? Well, I knew that from the tangent line, this red angle supposed to be same thing as this one. But at the same time, this angle supposed to be same thing as this one from the cyclic quadrilateral. Okay, so let's color something about the blue. All right, so here we go. We got some blue angle out there. That's same thing as this one. Why? Because that's a tangent line and we got a triangle. But at the same time, this blue angle is the same thing as this one. We got similar figure. And what is, we got an interesting similar figure. We have this thing being similar as this one.
저것들 왜 각도 같아요?
One at a time. 다시. Slowing down. Alright, slowing down. 빨간색만 봐봐. Just watch the red one. Okay. Slowing down. That's a triangle on the circle. Okay. You can see that the red equals red.
Why?
Because that's a tangent. Tangent point. Any triangle with tangents and tangents, they're same. 그치? Right, so let me erase this and now just try to focus on D's cyclic property. Inscribed angle. 똑같아.
그러면
똑같았지? 그치? 거기까지 심지어 나왔어. Right. Would you notice that AZ, BZ, they're also same? 왜냐면 tangents, radial axes, AZ squared equals ZX times whatever point that is. Shall we call it E?
Y라고 했어요.
얘 누구를 Y라고 했어? 얘를 Y라고 했어?
E가 Y예요.
E가 Y야? Okay, there's a name for it? 있네. Y가 있네. So ZX to ZY equals AZ squared. BZ squared equals ZX to ZY on the larger circle. So we found that AZ equals BZ. 거기까지 왔어. Alright, so here we go. If I mark this, what do you notice? That's such a parallelogram. This is such a parallelogram. Oh, this is such a beautiful picture. This is a parallelogram. But I'm not going to use any property of parallelogram though. 안 쓸 거야. I'm not going to use any special property of parallelogram. I know that all of these angles are same. I'm just going to focus on two things. 두 개만 갖고 갈게요. Right. So let me call PX as alpha. So that's alpha. This is 37. So you know that 37 to alpha equals alpha to 67. Alpha to 67. So we get alpha squared equals 37 times 67. Check. Power points. Let's go on to power points. From the bigger circle. From this one, please. From that one, please.
저게 뭐예요? PX가 뭐예요?
PX is this much.
그게.
근데 okay. So 천천히. This triangle is similar to this one. 닮음. We're using similarity. Okay. Since we're using that similarity, we can actually set that alpha squared equals 37 times 67. Okay. So this time, I want you to focus on that circle out there. Okay. I'm going to call ZX as beta. And you know that these are already cut into half. 얘네들은 벌써 다 they're parallelogram. So there must be some way that I need to find PZ, ZX, and 47. There must be some easy way that we can write it down. So here's what we're going to do. Check this out. PZ times ZX. And I'm going to call ZX as beta for sure. So PZ times ZX, which is alpha minus beta times beta, equals AZ times BZ.
Why?
Power of points. On the power of points, there are two chords.
아, 그쵸.
There are two chords. 1 and 2, 1 and 2. So just pure power points. No fancy stuff. So we get those information out there. And we're looking for AB squared though. Of course, like we need to get AZ and BZ squared, we're done. 끝났어. If we get AZ times BZ, we're done. But there's another way to see AZ times BZ too. How on earth do we check this? 이렇게 볼 수 있잖아. We know that from this circle's perspective, I told you that AZ squared equals ZX times that much, which is Y minus X. So alpha minus beta. Is this alpha minus? Yes. So beta times beta plus 47, yes, equals AZ times BZ. So they are the same. These are the same. So alpha minus beta equals beta plus 47. Too easy. Alpha equals 2 beta plus 47. Right, we're done. So classic. From now on, everything looks so, not super simple, but doable. You know, like this is totally doable. So, what is alpha minus beta? Alpha minus beta equals beta plus 47, right? And instead of writing, shall we change everything about beta? Because I know about alpha squared. So if I change everything about beta, what will happen? Beta will be alpha minus 47 over 2. So AZ squared is in fact beta, alpha minus 47 over 2, times beta plus 47. Whoa, that's what's up. And we're done. So, AZ squared equals, shall I multiply by 4? Because that's going to be better off. Alpha squared minus 47 squared. 37 times 67 minus 47 squared. And this is a number, which I give up as a solution.